Hello world and welcome. I'm Rick, and today I'm going to be talking about keyboard mapping for the Vice family of Commodore 8-bit computer emulators. This is the third episode in my series about finding a good keyboard mapping for the Vice family of Commodore 8-bit emulators and a MacBook keyboard. Last time, I started building my Vice keyboard mapping, or VKM file, by creating the mappings for the top row of keys on my MacBook. Working from my plan, I mapped the top row of the MacBook keyboard. This gave me the following mappings. This time, I'll tackle the second row of the keyboard, which is mostly the number keys, a few symbols, and the delete key. The second row is going to be trickier. Although the number keys are the same between the two keyboards, the symbols you get when shifting these numbers differ for a bunch of keys. And the keys following the numbers are quite different. There's not even the same number of keys. The Commodore 64 has 5 keys following the 0, the MacBook has 3. So let's get to work. Since the Commodore 64 has no key or even character matching either the backtick or tilde, that key on the Mac was open to whatever I needed. The key in that position on a C64 is a left arrow, a key with no equivalent on the Mac. So it seems reasonable to map the backtick to that arrow. Another unique key symbol to the Commodore is the British pound sign, and mapping that to the shifted backtick key, or tilde, is as good a place as any. First though, we need to find out what the name of this key is. That means using the keyboard debugger, which we did last episode. Just open the keyboard preferences and click the checkbox. With that enabled, if I type the backtick, I see the key code is grav. Okay. So grav maps to the left arrow key, at row 7, column 1. The left arrow key has no shift symbol, and I have plans for what I will do with tilde. So setting the shift flags to 0 will do what I need. That makes the mapping code grav710. And now I wasn't sure what to do next. I hadn't mapped a shifted key yet. Both run and clear were mapped to keys that worked with shift the same way. So escape mapped to stop, and shift escape mapped to run. Using the shift flag's value of 8 meant one mapping code mapped to both. But now I wanted to map the tilde, which is shift backtick on the Mac, to the British pound sign, a dedicated key on the C64. In other words, mapping a different key to the shifted version of a key. Time to look at the shift flags. This one looks interesting. 128, shift modifier required on host, meaning the shift key is held down when pressing the key. The pound key is at row 6, column 0, so we can map grav 60128. Testing this out, it doesn't work. In fact, it made the mapping for the backtick or grav stop working too. Looking at the flags again, there's another one of note. 32, another definition for this keysim scan code, follows. That would mean that we need to add 32 to the shift flags for the first of our pair of definitions. Now the left arrow is back, but we're still not getting anything for tilde. Notice something though? Look at the keyboard debugger. We see that the key being pressed isn't grav. There's a shift L for the shift key, but the key code it shows is ASCII tilde. So we put our backtick mapping back to what it was, and we map ASCII tilde to the pound key. And that doesn't work quite right either. The left arrow still works, but the tilde produces a filled triangle. Let's look at the pound key. Notice something? That filled triangle is what you get on the Commodore 64 when you press Shift and the British pound key. The shift we hold down to get the tilde is being carried over to the 64. So back to the shift flags. And there's flag 16, D-shift key for this keysim scan code. Let's try that, making our mapping ASCII tilde 6016. And it finally works. Moving on to the 1 key, which we find at row 7, column 1, and that's a simple mapping of the Mac 1 key to the 64's 1 key, 1700. And the keyboard debugger tells us that shift 1 is the key code exclam, which maps to the shifted 1 key on the Commodore. Checking the shift flags, we find that flag 1 is key combined with the shift for this keysim scan code. That means our mapping is exclam 701. Note that flag 8 would also work here, since you are holding the shift key down to get the exclamation point, and flag 8 means pass the shift key from the host Mac keyboard to the emulator. All the numbers are very easy, just mapping the number to its key matrix row and column. So 2 would map as 2730. On the Mac, Shift 2 gives the symbol @ which is also its key code. This is a dedicated key on the Commodore at row 5, column 6. We saw this before. We need to de-shift the key so the mapping will be @5616. 3 maps as 3100. Shift 3, or number sign, maps to 101. 4 is 130. Shift 4, or dollar, is 131. 5 is 200. Shift 5 has a key code of % and is 201. 6 is 230, but Shift 6 is a caret, or by its key code, ASCII circum, which is best mapped to the Commodore's up arrow key at row 6, column 6. Once again, we need to de-shift this with the shift flags of 16. 7 is 300. Shift 7, or ampersand, maps to the Shift 6 on the Commodore, so that maps as &231. 8 is 330. Shift 8, the asterisk, is yet another dedicated key on the 64 at row 6 and column 1, and we de-shift it again, so asterisk 6116. 9 maps to 400. Like Shift 7, Shift 9, or left parenthesis with key code left, moves 1 over on the Commodore to Shift 8, mapping to 331. 0 maps to 430. Shift 0 is the right parenthesis, or right, mapping to Shift 9 as 401. We can move right along to the minus key, and that is its key code, which maps 1-to-1 with the minus on the 64 at row 5, column 3, so -530. Since the Commodore 64 doesn't have an underscore character, I chose to map to a graphic character that was very similar. This is what we get by pressing the Commodore key and the @ key together. This means that I need to map a shifted key on the Mac to an unshifted, but combined with a Commodore key on the 64. How do I do that? Back to flags. And flag 2048 looks like what is needed. Key is combined with CBM for this keysim scan code. Note that CBM means Commodore Business Machines. In other words, the Commodore key. The key code is underscore. The @ key is at row 5, column 6. That makes our mapping underscore 562048. Trying this out, we find a bit of a magic trick. What's happening here? On the Commodore 64, the Shift-Commodore combination switches between its lowercase-uppercase character set and its uppercase graphics character set. So mapping underscore, which is really Shift minus, to the Commodore @ combo means that inadvertently we are also sending a Shift-Commodore sequence. So far, we've been using one flag at a time. You might notice that the values of these flags are powers of 2, 1, 2, 4, 8, 16, and so on. This lets them be combined together. That's actually what the term flags typically means. So we tried the combine with Commodore key flag 2048, but we need to get rid of the shift. And we know that's the 16 flag. Combine them to get 2064. That makes our mapping underscore 562064. This does the trick. We press underscore and we get a very underscore-like graphic character. Perfect. With that out of the way, we can map the rest of the line. The equal key, and that's its key code, maps to the 64's equal key at row 6, column 5. Shift equal gets a plus, and that is another one of Commodore's dedicated keys at row 5, column 0. We'll need to de-shift it, but that's simple now, right? The last key in the row is delete, which shows as a key code of backspace with the B and S capitalized. The Commodore 64 has a delete key as well at row 0, column 0. On the 64, Shift Delete is insert. As a quick aside, for a long time I remember reading this as instant delete, and I know I wasn't alone in that. So a key mapping that maps a host Mac key to a Commodore key and works shifted or not, we know this to use flag 8, making the mapping backspace 008. So Shift Delete on the Mac becomes insert on the 64. With that, the second row of the MacBook is mapped. I'll just step through it all together. And the new VKM file is growing, and row 2 is done. Or is it? Find out in part 4. Thanks for watching, and I hope you'll join me as things get colorful when we look at some of the more esoteric key mappings possible in the VKM file.